Hey everyone, welcome back with a new lecture with quality control, quality assurance training course. Today's lecture also around calibration, standard preparation, and how can you select calibration levels. As I explained in the previous lecture that calibration standard preparation is a very important step in any type of analysis to ensure the reliability and the accuracy of your measurements. So you should take care very well when you prepare the standards. And also, very important, how can you select the calibration levels? From which point you will start and up to which point you will finish your calibration levels? You should consider the following points. First point is LOQ. LOQ is the lowest concentration that can be quantified, not detected, quantified in the test sample with a repeatability precision, or we can say with accepted performance. With accepted performance. When you run or analyze replicate spike samples with lowest concentration that you will select, this lowest concentration that you will select, you will run replicate analysis of samples spiked with the lowest concentration that can be quantified in the test sample, and you will get the recovery should be within acceptable range, as example from 70 up to 120%. Relative standard deviation should be within acceptable range, also as example less than or equal to 20%, or according to the guideline you use. So accepted performance, all parameters should be within acceptable range to be as an LOQ, to be considered as LOQ. So LOQ, the lowest concentration of analyte that can be quantified in the test sample with accepted performance, accepted recovery, accepted relative standard deviation, accepted everything. So all parameters should be within acceptable range to be considered as LOQ. So you should consider, when you select calibration levels, limit of quantitation. How can you do this? As example, if you analyze only one analyte, and this analyte LOQ is equal to 5 microgram per kilogram. 5 microgram per kilogram. So your calibration levels will start from 1 point before LOQ. You should select 1 point before LOQ. As example, you will start from 1 BB. Don't start, better not to start from LOQ exactly. If you start from LOQ, that will be accepted also, but better to start by using 1 point before LOQ. Another very important point relating to LOQ also, if you have different analytes, not only one analyzed on the same run with different LOQ, and you want to prepare only one calibration for all of them, use 1 point before the lowest LOQ. As example, if the LOQ for all of these compounds different, like one of them 5 microgram per kilogram, another one 10, 5 and 10 as example, different. So you start 1 point before the lowest LOQ. So you can start also from 1, it will include both of them. Also, you should consider maximum limit or specification limit. Better to be included inside calibration levels. So you should have the highest level should be higher than or equal to the maximum limit. As example, if the maximum limit for target analyte is 100 microgram per kilogram, so you should have 1 point, which is the highest level, higher than this limit or equal to. So the levels should start from 1 point before LOQ, 1 point before LOQ, and end with the highest level, which should be higher than or equal to maximum limit. That will be the highest level. The last one, which is the working range. You should cover all concentrations you normally get for target analytes, if you can. As example, if you always get up to 100 microgram per kilogram for this analyte, not more than this. So you should cover this range of concentrations. You should cover up to higher than 100 microgram per kilogram. But if you always mostly get 500 microgram per kilogram or 1000 microgram per kilogram, and you cannot go for this level because of your instrument sensitivity, and that will be explained also. In this case, you can analyze the sample, and if you get concentration higher than the calibration levels, that should be diluted again to be included in the calibration levels. So if not any result, if you cannot do this, if you cannot include the range of concentrations you normally get for target analytes inside calibration levels, in this case any result higher than calibration level, any result will be higher than the highest level of calibration, should be diluted to be included inside calibration levels. So any result you will get should be inside calibration levels to be measured. Instrument sensitivity is a very important point because it affects everything. When you select also the calibration levels, you should take care from instrument sensitivity. If your instrument is new instrument and highly sensitive instrument, in this case it can quantify the lowest concentration accurately, but with highest concentration it can be saturated, and you will find the peak, you may find the peak like this. So that means the instrument is very sensitive and it cannot get this concentration. That's why at the beginning, when you develop your method and develop the instrument and start initiating the instrument, you should consider this point, saturation point during development stage. You should consider the saturation point for your instrument. You should know which concentration cannot be analyzed accurately with the instrument. So, as example, if this instrument is highly sensitive and it can only analyze up to 100 microgram per kilogram, 100 microgram per liter, so better your calibration levels, you don't go with higher than this calibration level, and any sample result you will get higher than this level should be diluted, as I said before. As here in this example, if LOQ equal to 5 microgram per kilogram, maximum limit or specification limit equal to 100 microgram per kilogram, and working range for target analyte, mostly you got result up to 200 microgram per kilogram. So better to start your calibration from one point before calibration or LOQ. So you can start by 1 LOQ and then 5, this is your LOQ, 10, 25, 50, 100. You can go for 100, or if the instrument can go for more than 100, so better to go for 200 to include also the working range and include the maximum limit. You can add another point. These are 6 calibration levels. You can add another point after 50. You can add 100. So you can add 100 and 200, both of them also. If the instrument saturated at this point, so in this case, don't add this point, but any result higher than this point should be higher than the highest calibration level, which is 100, should be diluted to be in between the calibration levels. So the relation now will be between the response, as you know, the response and the concentration. You will start from 1 up to 1, concentration 1, 5, 10, 25, 50, 100 or 200. If you can get 200, so it's okay. If not, you can go up to 100 only, and as I said, you should dilute. Saturation point means that the response not related to the concentration. When you run 200 microgram per kilogram as example, you got area under peak which is not relating to this concentration, not equal to this concentration. But for everyone here, one response which is area under peak, as you know, area under peak, this is the response that you will get for each concentration, area under peak. So 1, okay, 5, okay, 10, 25, 50, 100 all of them, and 200 if 200 okay, so you can add, better to include in these levels, and if not, as I said, you should dilute, but take care from this point, response should be related to the concentration. That was the end for our lecture for today, and in the next lecture inshallah we have also another two important points. If you have two groups of analytes and you want to run both of them using only one calibration to consume the time and to consume the instrument, everything. So what you will do, if these two groups with a very different concentrations, as example, if the LOQ for the group 1 equal to 0.1 microgram per kilogram, and for the other group 10 microgram per kilogram, so totally different, and the calibration also levels should be different. So what you will do in this case, you should mix them, and that will be explained in the next lecture, and how also you can plan when you prepare the calibration standards from powder standard. Thank you, and see you in the next lecture.